Good morning, students. This lesson is of class 8 for the subject of physics. Topic: Newton's second law of motion, which is covered in chapter 3, Laws of Motion, and is given on page number 64 of your textbook titled Concise Physics by Selena Publications. This lesson is submitted to you on 26th July 2021. Students, now you may all open page number 64 of your physics textbook. Children, before starting with second law of motion given by Sir Isaac Newton, let us first understand the concept of linear momentum. Now, children, linear momentum. It is defined as motion contained in a body. How to define linear momentum? It is defined as motion contained in a body, and mathematically it can be defined as product of mass and velocity of body. Children, linear momentum is a vector quantity. It is a vector quantity and is denoted by letter small p. We will take small p as linear momentum. So let us write down its formula. Linear momentum is mass multiplied by velocity, that is m into v. Now children, the direction of momentum, since it is a vector quantity, it depends on direction, and the direction of linear momentum is along the direction of motion of the body, that is along the velocity of the body. SI unit of momentum can be written as kilogram meters per second. Mass is measured in kg, velocity is measured in meters per second. So the standard international unit comes out to be the product of mass and velocity. Similarly, if we want to write down the CGS unit, then mass will be calculated in grams. Velocity is to be calculated in centimeter per second. So my answer comes gram centimeter per second. Now children, you may take a break of 5 minutes, and in the meantime solve the numerical, which you can see written in the last 3 lines of the first page of the PDF sent to you on 26 July 2021. So see what is the question, children? A body of mass 3 gram is moving with velocity 8 meters per second. You have to calculate the linear momentum. So I'll just give you a hint. Children, one unit is in CGS, the other is in SI. So you can convert grams into kilograms such that your complete answer comes in SI unit. So now do it yourself, and then you can check the answer later. So I hope you have done, children. See, mass is 3 gram, which can be written in 3 into 10 raised to power minus 3 kilogram. Minus 3 means that there are 3 zeros in the denominator. So 3 upon 1000 can be written as 3 multiply 10 raised to power minus 3. Velocity is 8 meters per second. So children, linear momentum can be written as mass into velocity. Put the value of mass and velocity such that your answer comes to be 24 multiplied by 10 raised to power minus 3 kg meters per second. Now children, let us study change in linear momentum, which is written as delta P. This symbol delta, this triangle symbol, is known as delta. And it is usually used to depict the change in any physical quantity. So that means delta P means change in momentum. Change in linear momentum can be written as difference between final and initial momentum. So children, final momentum can be written as m into v. Initial momentum can be written as m into u. And children, in this case, which is written as starred equation, the masses are taken to be same. But if the mass is not constant, then you have to write down m2 into v minus m1 into u. So change in momentum will depend on whether the mass remains constant or not. Coming further is second law of motion. Children, the first law defines the force qualitatively. That means the quality of force required. Is a force required to change the state of motion, or it can cause motion, or it can stop a moving object? But children, how much force is needed is not answered by first law. For example, if there is a table lying in front of you, then according to first law of motion, a force is required to move that table. But now the question arises, how much is the force needed to move the table? Now this question is answered by Newton's second law of motion. So the second law of force given by Newton defines the force in quantitative manner. Quantitative means the quantity will be told here. And according to this law, force can be defined as rate of change of linear momentum. Change of linear momentum. First of all, this is the definition of force here. According to Newton's second law of motion, force can be defined as rate of change of linear momentum, children. And if we want to write down in symbolic form, delta P stands for change in momentum, and the word rate means time divided by time. So this becomes the formula here, that force is equal to rate of change of linear momentum. So F is equal to delta P by delta T. So children, if velocity of the body is v, which is very less than velocity of light in air, then we say mass is constant, and we get formula of F as mass into acceleration. So F is equal to ma is possible only with mass of a body is constant when it is moving. But if mass is variable, then F is not equal to ma. Then your answer changes. So F is equal to force is product of mass and acceleration is always possible if mass is constant. Otherwise, it is not possible. Children, force is also a vector quantity, delta P by T. It is a vector quantity, force. And we will be using the formula F is equal to ma in numericals, where m will be taken constant if the body is in motion. Now, according to these variable F is equal to ma, we are having three graphs. If A is taken along y-axis and F is taken along x-axis, children, just see how I am writing down the graph. You have to write down what is on y-axis and what is along x-axis. So there are three variables. F is ma. So let us draw a graph between F and A, keeping mass constant. So this is a straight line. Similarly, if I draw a graph between F and M, keeping A constant, it is again a straight line. While if I draw a graph between A and M, keeping force, the third variable, constant, the graph is a, what is kind of a graph here? It is a curved graph. And when you are making it, make sure you are not touching the graphs at x-axis and y-axis. It is not to be touched. Is it clear? So in the third graph, children, kindly be careful while drawing this graph. You are not supposed to intersect this graph with x and y axis. So now let us study the units of force. The standard international unit of force is Newton. Force is measured in Newton, and 1 Newton is 1 kg mass and 1 meter per second square acceleration. So 1 Newton can be written as, how to write down? It is the force which, when acts on a body of mass 1 kg, produces an acceleration of 1 meter per second square. So it is the force which, when acts on a body of mass 1 kg, produces an acceleration of 1 meters per second square. Now CGS unit of force is dynes. And 1 dyne, since it is CGS, it can be written as gram into centimeter per second square. So the definition remains same. You have to just write down the different form of units. So 1 dyne is force which, when acts on a body of mass 1 gram and produces an acceleration of 1 centimeter per second square. So children, the relationship between force in a Newton and dynes is as shown below. So here, see, 1 Newton means 1 kg, 1 meter per second square. Now let us convert the quantities. 1 kg means 1000 gram, meter means 100 centimeter. So now total the number of zeros here, there are 5 zeros as written above. So we can say that 1 Newton is 10 raised to power 5 CGS unit, which is dynes. So the relation comes out to be 1 Newton is equal to 10 raised to power 5 dynes. So now students, Newton's second law is known as the real law, as the first and second law can be derived from this law only. So which is the real law of motion? Newton's second law is termed as the real law of motion. Am I clear, children? Now, according to second law of motion, force is directly proportional to change in momentum divided by time. It means that force is directly proportional to change in momentum, change in linear momentum. Direct relation means if you increase momentum, if you increase the change in momentum, not just momentum, the change in momentum, then the force will also increase. Similarly, force is inversely proportional to time. Inverse relation means if time required to for the change in momentum, time required for the change in momentum is more, then force exerted will be less. So children, this second part which I have written here, now this second part will be used for the examples of second law of motion. So children, I request you all to go through these two examples and understand that if we increase time for any event to occur, then the force experienced will decrease. So kindly do these two examples yourself, and then you may start doing numericals given on exercise 3C on page number 70. For doing so, you have to take simple formulas, that is P is equal to mv and force is equal to mass into acceleration. So children, this time kindly try these numericals which are given on the PDF and try to do these questions yourself also. So with this, I come to an end to this interactive session. You may do the numericals and we can take your doubts in the online classes also. So thank you, students. Have a nice day.